When you think of nylon, what comes to mind? Do you think of that stretchy material in your yoga pants? Or those plastic spatulas in your kitchen? Now, when we say Kevlar, what do you think of? Probably not bulletproof vests, but that's what they're made of.
Nylon and Kevlar are actually really interesting substances classified as polyamides with many important uses. Polyamides are polymers in which the repeating units are held together by amide bonds.
Both nylon and Kevlar form from a reaction called condensation polymerization. All condensation polymers are created through this reaction. It is the formation of a polymer that involves the loss of a small molecule, usually water. The monomers involved in condensation polymerization are characterized by the fact that they have functional groups instead of double bonds, and usually two reactive sites.
To make nylon, first cyclohexane is obtained from crude oil and oxidized to form adipic acid. Separately, adiponitrite is hydrogenated to form hexamethylene diamine. Then, adipic acid and hexamethylene diamine undergo a condensation reaction to form nylon salt. This nylon salt is then put into an autoclave, where it is heated to 280 degrees Celsius under 18 atmospheres to remove the water that formed during the condensation reaction. This creates nylon. To prepare it for distribution, the molten nylon is forced through tiny holes to form laces. These laces are placed in water to cool, then chopped into 3 to 4 millimeter long granules, which are sent away for production.
Nylon is a very popular plastic. It became extremely useful for the textile industry during the World War II as an alternative option to silk. It was dubbed the miracle fiber. Fun fact, Betty Grable, an actress, once sold a pair of nylon socks for $40,000 as part of a war fundraising effort.
Nylon was used for parachutes, ropes, cords, and aircraft tires. What made nylon so desirable was its toughness and the fact that it is lightweight and waterproof. The amide group is what makes nylon so tough. When spun, amide groups form hydrogen bonds with the carbonyl groups on the carbon chains next to them. This is because the long polymer chains line up next to each other.
Nylon is also used in a lot of fabrics. This is due to its elasticity, strength, and availability. It is the most common fiber for textiles and can also be easily dyed. An important staple in the fashion industry, it is used for a myriad of clothing items: swimsuits, socks, gloves, hats, backpacks, wedding gowns, and much more. Fun fact, the name nylon is a combination of New York and London.
To make Kevlar, you react paraphenylene diamine with terephthalonyl chloride. To make Kevlar, water, and hydrochloric acid. Then you weave the Kevlar into long, thick strips.
Kevlar is a prime example of cross-linking of polyamides, which gives it very special properties. It is light as a feather and extremely durable with its stronger than steel properties. Due to its extreme durability, this material is used for bulletproof vests, fireproof clothing, sports equipment, and aircrafts. The sheet-like structures of Kevlar is held together by polymer chains that form a strong network of hydrogen bonds. The molecules can pack closely together and the hydrogen bonds strengthen it further. Kevlar is often called the super fiber.
Now let's talk about how nylon impacts the earth. Firstly, nylon, just like polyester, is made from non-biodegradable chemicals. The process of making nylons also requires a large quantity of water and crude oil to obtain the cyclohexane, making it extremely wasteful. The production of nylon also produces nitrous oxide, which is a greenhouse gas 310 times more potent than carbon dioxide. not to mention that it has an atmospheric lifetime of 150 years. In terms of recycling of nylon, it cannot be melted down and used again. Therefore, it must be broken into its original chemical components, requiring more resources to recycle and make once again.
Just like nylon, Kevlar is not biodegradable and produces a lot of byproducts during its synthesis. It takes a lot of resources and energy to produce the final product.
Kevlar may be the superfiber, however, we disagree with the manufacturing and use of this polymer on a larger scale. It is non-biodegradable and wasteful. It also has a great alternative called the ABC matrix.
We also do not agree with the mass production and commercialization of nylon because of its negative effects on the environment. Although there are also pros of using nylon, it is not a sustainable or renewable resource. Waste from the creation of nylon accounts for 2% of the nitrous oxide in the atmosphere. There are alternatives to using nylon as a fabric in a textile, and time and money should also be invested into finding a sufficient, more eco-friendly replacement that will cause less detriment to the environment.
Thanks for watching!